In a previous video, we learned how to name ionic compounds. In this video, we're going to be writing formulas for ionic compounds. So first, determine the charge of both the anion and the cation. Then, we'll assign appropriate subscripts to ensure the compound is electrically neutral. A way to ensure the compound has the right number of positives and negatives is to use the zigzag method. So you'll need your periodic table, and remember, on top of each group, there's a number written, and that number tells you the charge of those atoms when they form ions. So for example, calcium always has a charge of +2, and fluoride always has a charge of -1. And once again, you know this because on the top of your periodic table, in group 2, where calcium can be found, you've written +2. And on the far right of your periodic table, where fluorine is found, in that group or family, you've written -1. So fluoride has a charge of -1. So if calcium has a charge of +2, how many fluorides would we need to balance out +2? Well, of course, we would need 2 fluorides. So you can think about it in terms of making it electrically neutral. How many of each do we need? Or you can simply use the zigzag method. Most students decide to use the zigzag method simply because it requires a little less thought. So, remember, fluoride has a charge of -1. So it's like we take that 1 and we bring it down behind calcium. And then we take this 2 and we bring it down behind fluoride. So it's Ca1F2. And notice we're really not writing the 1. The 1 is just implied. Okay, let's write the formula for barium phosphide. So find barium on your periodic table. It's in group 2 and it has a charge of +2. Phosphide, that's the ion of phosphorus. And phosphorus, when it forms an ion, has a charge of -3. So let's go ahead and zigzag these charges. We'll bring the 3 down behind barium and the 2 down behind phosphorus. So when we write the formula, it's Ba3P2. So take a moment to understand exactly how we're crossing these charges. And I know that eventually we get to the point where we just do this quickly, but remember the point behind doing it is to ensure that barium phosphide is electrically neutral or has the same number of positives and negatives. All right, we have cobalt-2 chloride. Now you'll need to recall, what does this mean, cobalt-2? Now most students default to what they think it means, and they think it means that there are 2 cobalts. But you've already watched the video, so you know better than that. You know that this Roman numeral 2 does not tell us that there are 2 cobalts. Rather, it tells us what the charge on cobalt is. So cobalt here has a charge of +2. Now, cobalt's a transition metal, so there would be no way of knowing what the charge was unless it was given to you. And chloride is in group 7A, and it always has a charge of -1. So let's zigzag them. So CoCl2. You need 2 chlorides to balance out 1 cobalt. All right, magnesium oxide. Here's the symbol and the charge. The symbol and the charge. I would encourage you not to go straight from the words to the formula, but start by writing the symbol and the charge. You may find that to be very helpful. In fact, if you discover that you're not getting some of these problems correctly, then I would suggest you it's necessary for you to write the symbol and the charge above the words. It's very helpful because that kind of, helps us accomplish this in the scaffolding type fashion where we look at it in smaller increments or steps. So, this is a ratio that we have, 1 calcium to 2 fluorides. What's the ratio here if we zigzag this 2 and 2? Well, 2 to 2 is 1 to 1. So as it turns out, what we're able to do is to reduce these. So it's just Mg1O1. Remember that these represent a ratio. That means for every one magnesium, we have one oxide. All right, let's do aluminum oxide. Aluminum has a charge of +3. Oxide, as you remember, has a charge of -2. So when we cross them, it's written as Al2O3. Now let's do lead-4 oxide. Once again, lead-4 doesn't tell us that there are 4 leads. It tells us what the charge on lead is. And the charge on lead is +4. The charge on oxide is always -2. So we're going to zigzag these things. So you may expect to see subscripts of 2 and 4, but remember that this will be a ratio of lead to oxide. So we can reduce this not to 4 and 2, but to 2 and 1. So when we cross them, it should be written as PbO2.